Okay guys, so in this video let's talk about binary search. Okay, in the previous video we have talked about linear search, right? So recall the best case time complexity and worst case time complexity of linear search algorithm. It will take O of n, right? That's the worst case time complexity. Okay, so linear time complexity. Okay, worst time is O of n for linear search. Okay, LS. Here I'm gonna teach you binary search, which is way much simpler than the linear search. Okay, and it's going to take very lesser time than the linear search. How it is possible? And I'll tell you why. There is no need for me to compare each and every element. So no need to examine each and every element in binary search. No need to examine each and every element, right? You can directly get the element. How it is possible? And that's how binary search magic works. Okay, so let's see. Okay, let's take an example. Fine. So this is my array, let's assume, and let's say I have elements, say 10, 20, 30, 40, 50, right? So I have 5 elements. Let's go with that, or I can go for one more element. Okay, before that, let me have the element in some random order, guys, because I have been telling you about only the sorted elements, right? Let me have elements in random order, so that that is one more point here to understand. Okay, let's say 7, 5, 13, 15, 17, 11. Okay, so these are my elements. Okay, and this binary search has a prerequisite. Okay, this has a requirement. What is the requirement? You have to sort the array. Okay, you have to sort the array before you locate any element. Before you locate, you have to sort the array. Otherwise it won't work. The binary search algorithm won't work. The binary search algorithm demands that the array should be sorted. Okay, and you can see that this array is not sorted, so first step would be sorting the array. So you can use sorting techniques, which I will be teaching you later. So let us assume the sorted array now. So sorted array, okay, that's the first technique, right? So what will be sorted array? 5, 7, 11, 13, 15 and 17, right? So this is my sorted array. Okay, then only you can apply your algorithm. Okay, the algorithm goes like that. Okay, so without having the sorted array you can't proceed, right? All right, so now what you have to do, you just have to choose the last element, the first element and the mid element of the array. Okay, let's say my mid element is 13. Okay, the middle element. Okay, so this array has 6 elements, so the mid element would be 6 plus 1 divided by 2. So 7 by 2 will become 3.5. So either you can take third element or the fourth element as the middle element. Okay, since this array has even number of elements, this goes a problem like that. If the array has odd number of elements, then you can exactly locate the middle element, right? And you're getting it, right? So I'm choosing this as my middle element. So this is my first element, this is my last element, and this is my middle element. This is the second step, guys. First step is sorting, whereas second step is choosing the first, middle and the last element, right? So you have to do like that. Okay, the third step goes like this. After choosing the middle element, let's say I'm searching for a particular element. Let's have the search element first. I'm searching for 11. Okay, I'm searching for 11. All right, so the third step would be comparing your middle element and the element which you are searching for. Okay, understand that the element which you are searching for is 11, and you have to compare the middle element. Okay, so the middle element, you have to compare whether the middle element is greater than or lesser than your searching element. Okay, let's say my middle element is here is 13, so I have to check whether 13 is greater than 11 or lesser than 11. All right, so go for one check if 13 is greater than 11 or lesser than 11. Okay, so here the 13 is greater than 11, right? 13 is greater than 11, so this is true, which means my middle element is greater than the element I am searching for. Okay, the middle element is greater than the element I am searching for. In other words, I could say the element which I am searching for is lesser than the middle element. Okay, that is 11, which is lesser than the middle element. That's the correct way of arguing. Okay, then what I have to do, if that is the case, then it's very simple for me. If that is the case, then here we have found that the element which we are searching for is lesser than the middle element, right? So if that is the case, then there is no need to search this particular part, right? Understand that if the element that you are searching for is lesser than the middle element, then there is no need to search this particular part, right? You can search only for this part. Okay, you can neglect this side of the array. Okay, because the array is in sorted order, right? So you can neglect this side of array. Okay, now what you have to do, to neglect this side of array, you have to make 13 as your last element. That's it, 13 as your last element. So 5, 7, 11, 13. So this is my last element, this is my first element. Now again you have to choose your middle element. Let's say my middle element is you can choose, right? You can choose any one element because it's another even number of elements. You can choose, say 7 is my middle element. Again you have to compare. Middle element is greater than element you are searching, or middle element is lesser than the element you are searching. It is obviously greater than the element you are searching, right? So this part can be omitted. This side of the part can be omitted because the middle element is greater than the element that you are searching. I mean, the element which you are searching is greater than the middle element, right? Again you have to choose your middle element, then compare the element which you are searching, whether it is greater than the middle element or the element which you are searching which is lesser than the middle element. Of course, the element which you are searching, which is 11, is greater than the middle element. Middle element here is 7. Okay, I have chosen middle element as 7. So if 11 is greater than 7, if that is the case, then there is no need to search this part of array. Even if you have elements here, there is no need to search, right? Because you know that your 11 is greater than your middle element, right? So what you have to do here is you just have to make this as your first element now. Okay, make this as your first element. Again choose your middle element. Now it is 11. Okay, and compare your middle element. Middle element here it is equal to 11. Then stop the process. Okay, middle element now equal to 11 and stop the process. That's it. So here the main point to understand here is the middle element comparison. Okay, and if the middle element once you have encountered that is equal to the element that you are searching for, here you have chosen 11 as middle element and that is the element that you are searching for, then stop the process. That's it. Okay, let me quickly recall the algorithm once again. Alright, so I'll have a sorted array first. So first of all you have to sort the array. So let me say 1, 2, 3, 4, 5, 6, 7, 8 and 9, right? So I have 9 elements. I'm searching for say 3. Okay, I'm searching for 3. I'm searching for 3. First, what is the step? Choose your first element, last element and the middle element, which is 5 here, right? And the element which I am searching for 3, obviously it is not equal to the middle element, but it is lesser than the middle element, right? 3 is lesser than the middle element. Then ignore this part. If so make this middle element as the last element. Search only this array. Okay, make 5 as your last element. Okay, after that you have to choose your middle element again. So let me choose 3 as my middle element, right? And the element which I am searching for is also 3 and that is equal to the middle element, right? So here it is middle element. So stop the process. That's it. Okay, so it's very simple algorithm, right? So you have to omit, you can omit one particular side of array depending upon the comparison, whether the middle element is greater than the element which you are searching or it is less than the element which you are searching, right? So based on that you can omit one side of the array, and after that you have to use that array, first element, last element, and again choose the middle element, right? You can go for that, and this is a very easy process. Again, we are not, the important point to note here is we are not searching the whole array, right? We are not searching the whole array. We are actually omitting one side of the array. So at the end of the day, we are not actually traversing, examining each and every element. Here you can see there are 9 elements, but we have once made one comparison, we have actually omitted one side of the array, right? So we are not searching the whole array. So this method has a time complexity O of log n, which is much better than O of n in case of linear search. Okay, so O of log n is the worst case time complexity of this particular algorithm. Because why it is O of log n means log n where it will come when the problem is cut off by a division. Problem is cut off by a division, which means when your problem is is getting cut off by a division. Say the first I'm making 5 comparison, in the next step I'm making only 2. Okay, let's go for this example. In the first step I'm making 6 comparison, in the next step I'm making only 3, in the next step I'm making only 1. So the problem is getting way easier, right? It is getting reduced. Okay, the number of steps is getting reduced. That's why it is called as problem is cut off by a division. So the idea here is log n. Okay, the worst case time complexity. Again, the best case time complexity would be O of n. Okay, why? Where it comes when you search for the element which is exactly the middle element. Let's say this is my sorted array. Okay, so first of all you have to sort the array, don't forget that. Let's say I'm searching for my middle element is 3. This is first element, this is last element. Let's say I'm searching for 3 alone. So in the first step itself I'll get the answer, right? So I'm searching for the 3, that's the middle element. So I'll get the answer. So I'll execute this program only one time. That's it, right? O of 1. And it depends upon the cases that we are going to give. It depends upon the example that we are going to give to the program. Okay, it will work in worst case, or it can also go to best case in sometimes. That's all about binary search. I hope you have understood this. Thanks a lot. Yeah, welcome back, guys. So in this video we'll be implementing binary search. I hope it's recording. Yes, it is. So we'll be implementing binary search. Okay, so I think in the previous video we have seen the algorithm of binary search, how it is working, and in this video let's actually implement that using C programming, right? All right, so binary search algorithm, you need some variables. First of all, first you have the array. You have to declare the array. Okay, because you are implementing this search and sorting algorithms using array only, because those are some easy data structures, so that it will be more compact to implement those algorithms in using these data structures, maybe array or linked list. Okay, but binary search you can implement only using array. Okay, you can't implement that using linked list. Why? Because binary search is a linked list is a dynamic data structure. You don't have a fixed size. Okay, it's a dynamic data structure, and you can even add a lot of elements, right? I told you, right? It's a dynamic data structures, and you can the memory is allotted during the runtime of your program. It is not static. Whereas array is static. Say if I say 100, it is static, right? This array can store 100 elements, right? That is the limitation. Okay, you can't manipulate that inside your program. Whereas a linked list, it's completely dynamic. You can manipulate the size. So because of that reason, and the linked list binary search is not possible, and also it is not so efficient to sort the linked list. I told you in the previous video, please keep that in mind. If you want to implement binary search, then the array must be sorted. That is the first prerequisite you have here. The array must be sorted, then only you can implement binary search. Otherwise it's not possible, right? So array must be sorted. Please have that in mind, right? So let's get the array first. I think I have my linear search code here, which we have written 2 videos before. So let me just copy paste some template code. Okay, just getting the array as input, right? So these are just template code which I have already explained. I'm not doing anything. I'm just getting the size of the array and the array elements, right? This will be same for all the searching and sorting algorithm, guys. This particular set of code will be same. Getting the size of the array and getting the array elements. That's why I'm just copying that from the linear search, right? Uh, I hope I can do that, right? Super. All right. So I've declared an array and I'm getting the array elements, right? I think I may be in need of a lot of variables here. I'll tell you why. Okay, and I need a variable called first, which will store the index of the first position or first element. Why I told you in the previous video, why do you need that, right? Whenever you want to implement binary search, you should have first element, last element and the middle element, right? So first, that variable will store the index position of the first element, guys. It will not store the exact element. Okay, it will not store the exact element. It will just store the index position of the first element. The let's say my array contains 10 20 10 120 34 56. Okay, these are my array elements. I have only 4 elements, right? Then first will not store 10, guys. It will not store 10. First will store the index position, which means the index position of 10 is 0, right? Because array index starts from 0. So first will have the value of 0. Okay, and you have last variable also. It will store the index position of the last element. Okay, and index position of 56 is 3, right? Because 0 1 2 3. So last will store the index position of the last element, which is 3. So it will store the index position, guys. It will not store the exact element. I am explaining you this because this may confuse you, right? So first, last, and I have one more variable which is similar to first and last. I have middle also, and middle is something important in case of binary search, right? Because we are making comparison only based on that middle variable. I explained the algorithm clearly in the previous video, right? Super. And I have n to which basically denotes the size of the array, and I have the element which I wish to search for, right? That is called as search. Okay, so search is the element which I wish to search, right? All right. So I think I have to get the element also, right? Okay, I've got the size, I've got the array. I have to get the element which I wish to search, right? So let me copy that code also. The element which I wish to search. All right. So this is the and I'll be entering the element which I wish to search, right? So that's it. After that, I think yeah. First of all, let us have the first element to be 0, because by default the first element will have the index to be 0. Again, I'm repeating that is the index value, right? By default, array index starts from 0. So let me have first element to have 0. I mean the first variable to have 0, and last will be n minus 1, right? What is n minus 1? N minus 1 is nothing but the size minus 1. Okay, last is the index of the last element. An index of the last element will be n minus 1, guys. Okay, I could give you a short example. Let me take this example, right? And this is an array. Okay, this is an array. And what is the index value of, I mean, what is the size of this array? Size of this array is 4, which means this array will contain 4 elements, right? And that is n. N is the size of the array. Okay, you are getting the size of the array here. So n equals to 4 here, right? And index of first element is 0, 1, 2 and 3. What is 3? 3 is the index of the last element, which is 40, right? So index of the last element is 3. 3 is nothing but 4 minus 1, right? Which is size minus 1, right? So n minus 1. So you have to write the last element's index as n minus 1. That is size minus 1. Because since the index starts from 0, the last element will have the index n minus 1. That is size minus 1, right? And the middle will be the average of first and last, guys. That's it. Okay, and you are performing integer division only, so you will not get float values here. You will only get the integer values, right? First plus last divided by 2. All right, and I have to open a loop here. You know that, right? So the loop will continue, okay, until my first index, that is first index is less than last index, right? So till my first index becomes greater than the last index, the loop will continue to execute, right, till my first index is greater than the last index. Understand that sentence. Okay. You know about binary search algorithm. If you have any doubts, please go back and watch that algorithm video, right? I have explained this. So first element should be less than or equal to the last element, right? I mean the index values, right? And for each iteration, you have to check this condition. Okay. Array of middle. Okay. I think it's R. The array of middle, that's the middle element. Okay, as you can see the middle element here. Okay, so array of the middle position. Okay, middle will store the index value again, so array of that index. Okay, that element, whether the array of middle, that middle element, array of middle element is less than the search, which means the element which I wish to search. That is the algorithm, right? You have to compare the element with your middle element. Compare the element that you wish to search with the middle element. If that is less, then you have to omit that one part of the array. I hope you remember the algorithm, right? So I say my 30 is the middle element. Okay, I am searching for 35, and if 30 is lesser than the middle element, then I can just omit this part of the array. There is no need for me to search 10 and 20 because my middle element is less than the element 35 which I am searching for, right? So I'll be just searching this right part of the array. You know that, right? So I have to input this condition, and if this is true, then I have to make, if this is true, then I have to make the middle element as the first element, guys. First equals to middle plus 1, right? Why? Because there is no need for me to search left part if my if 35 I am searching is greater than the middle element, that is 30. So there is no need for me to search this part. So make 30 as your first element, that is make middle element as your first element. That's it. Very simple, right? Easy peasy. Okay, I mean this concept is very simple. The element you're searching for is less than the middle element, then make the middle element as the first element and search only that part, right? Super. And you have to use else if later. So I'm including one more condition, else if this is not true, then check one more condition, which means the array middle, the middle element is equal to the element that you are searching for. I mean the element is found. Okay, the middle element is the element you are searching for, the element is found. If that is the case, then you have to print that the element is found at position %d, and the position you have to say, so that is middle plus 1. If you are following me from the linear search code itself, then you should be definitely able to understand why I am writing middle plus 1, right? If you have any doubts, please go back and watch that video in linear search C programming. In that video I explain why I am putting index plus 1. Middle is just an index, right? So index plus 1, why I am putting that. So, and this is the end case, right? This means that I have element is found, so I am printing that and I am breaking the loop here, right? Super. And if, yeah, so till the loop will stop, if the element is not found, then you have to search one part of the array. If the element is found, then just print and break it, right? And after coming out of the loop, if the first element becomes greater than, if the index of the first element becomes greater than that of the last element, then printf the element is not found, because you have made all the separations, you have made all the binary separations, and you can't find your element, you can't fulfill this condition, then your first element will definitely become greater than your last index, right? If that is the case, the element is not found. That's it. And you end that loop here. This should be given after the end of the loop. I mean, this should be given outside the loop, right? This should be given outside the loop. That's it. I hope this code will work now. I think I have to give one more condition, right? So here you can see I have to give one more else part. Here you can see that the middle element is less than search. That's okay. what if my middle element is greater than search? Okay, the middle element is greater than the element which I am searching for. Okay, let's say the middle element is 30 here, the element which I am searching for is 20, which means that I have to omit the right part of the array. Okay, I have to omit 40 and 50. If I have one more element here, 50, I have to omit the right part of my array. Middle element is 30, but element I am searching for is 20, which is obviously lesser than the middle element. If that is the case, then I have to omit this part. 40 and 50 should be omitted, which means that 30 should be the last element, right? 30 should be the last element. So in that case, if I wish to search an element which is lesser than the middle element, then I have to make the middle element as the last element, right? So here I just have to make the middle element as the last element. That's it. Middle last equals to middle minus 1. Always have this middle plus 1 and middle minus 1 here. Okay, that's just for normalization sake, right? Yeah, I think this will work. And I have to so till I have to iterate this loop, right? So I have to make middle to be first plus last divided by 2. This is the average condition that I have to give in this loop to iterate, right? Otherwise the loop will not iterate, right? Yeah, I think this will work. Yeah, super. Let me run the code. Yeah, I is undeclared, right? So let me declare that somewhere here. And one more error is that array undeclared. So I think I have wrongly used the word array. I have to use ar. Sorry. I think this will work. Yes, size of the array is 6. Let's go for that. 10, 20, 30, 40, 50. Okay, 10, 20, 3 not 4, 50, 6 not 2. Alright. And one more element, 34. Okay, fine. So I wish to search 50. Element is not found. Oh my god. Oh my god. 50 is there, right? Somewhere here the error is there. Let's run the code. Let's check whether it works. So I'm giving the size as 4, and I'm giving the elements 11, 22, 33, okay, 3, 44, searching for 22, and it says the element is found at position number 2, because 22 is found at position number 2, and yes, this code works perfectly, right? Yeah, to understand this more efficiently, try to code this algorithm, okay, by yourself, so that you will be able to get this if you have any doubts. And if you still have any doubts, you can always go back and watch the algorithm video again. Thanks a lot, guys.